Hi. Good morning. Welcome back. How you doing?
I'm very well.
Good.
Spectacular.
So these notes should feel really familiar to you, especially if you took Algebra 1 here with us.
Yes, ma'am.
I ripped these from the Algebra 1 too. I borrowed
I had Miss Cavazos.
from... So in Algebra 1, you started doing systems of equations. And so I want to check to see what you remember. What is a system of equations?
It's. Oh my gosh, I forgot.
I forgot. I had a shrug. It was too long ago. Okay, at the risk of just making a mistake and saying something that makes no sense, what do you think a system of equations
Or like,
is?
I'm looking at this. Isn't it like 2 lines?
2 lines? Multiple equations? Yeah, that's exactly what they are. They're multiple equations. It's going to give us more than one line, depending on the equation. You could have lines, you could have parabolas, you could have squiggles, you could have circles. I don't know. It just depends on what the equation is. But it is multiple ones, 2 or more. And so we're going to be focusing on 2 systems of equations right now. That's what this means, 2 by 2. It means we've got 2 equations and 2 variables. We're going to be using a method called substitution to figure out the solution to these equations. So let's start with the remember this. When you see this, what do you think?
The first one's easy.
Okay, what do I do?
You just substitute the 1.5 and you put it where the x is at, so you multiply.
Perfect, let's do that.
Yeah.
So f of x becomes f of 1.5.
Equals 7.
And 7x minus 2 becomes 7 times 1.5 minus 2. All right. Help me out with some numbers here because I cannot multiply very well in my head.
It'll be like 7.5, no? Because. Oh, never mind.
Use your favorite calculator app.
Oh, yeah. Oh, it's 10.5.
10.5.
How is? Oh, never mind. I put the 7 on the top instead of the 1.5 on the top.
That's all right. And then I can do maybe double check my subtraction of 10.5 minus 2 because, yeah.
I think, yeah, it's correct.
So what this line means, I need to tell a story before I can tell you what that means. Bless you.
Story time.
So system of equations, you were right in saying it's, 2 lines, it's multiple equations. Where we typically use systems of equations in the real world is in a business mindset. Say, for example, you were wanting to have a fundraiser and you're trying to raise money because you want to help out mom and dad with down payment on a brand new car. They said, I'll get you a car, but you gotta come up with $1,000, okay? And if you can give us $1,000, we'll buy you the car, okay? I wish my dad had done that. He did not, right? The sadness and the heartbreak. Oh. So anyway, I got to raise this money. So I decide I'm going to start selling bags of Chamoy Gummi Bears,
Pancho.
right? Like everyone in this room is like, I'm going to buy 5 of them a day. So I need to figure out how much money I should start with, how much these gummy bear chamoy things are going to cost, and then how much I should sell each bag for so that I will recover my money fast so I can start making money toward my $1,000 that I need for my car. Okay? That's a system of equations. One equation tells you how much money you're going to have to spend on each bag of Chamoy Gummi Bears, and the other equation is going to be telling you how much money you're bringing in by selling these bags of Chamoy Gummi Bears, and where the 2 lines intersect is what in the business world they call the break-even point.
Oh.
That is the moment in time in which the money you bring in exactly covers how much you spent making those bags of Chamoy Gummi Bears. Every bag sold after that is just money into your pocket. It's profit. Okay? And so what this line is telling you in that little story context is that if this is my function of how much money I'm making off of each bag of chamoy. Then f of 1.5 is telling me that when the number of units of Chamoy Gummy Bear bags I've sold is 1.5, the money I'm making is 8.5 units of money. Whatever that means. Like it could be dollars or pesos or, I don't know, $20. I don't know what unit of money I'm counting in. I don't even know what unit of bags of Chamoy Gummy Bears I'm counting in, but
They can be like different, like.
they could be slightly different units, but that's what this means. This means that at the moment I've sold 1.5 units of Chamoy Gummy Bears, I have made 8.5 units of money. Okay? Let's talk about this one. What do I do here? I'm going to substitute. So instead of the y, I'm going to put a -4. Alrighty. Solve this thing for x, and it's going to tell me how many bags of Chamoy Gummy Bears I would need to sell in order for me to have -4 units of money. Okay, look, that's -6 to both sides. Okay. When we're talking buying and selling things and money, negatives mean that I haven't sold them, or that I've used money and haven't made money. Okay. And then here I would divide both sides by 0.5. Okay. And your calculator says it's
-2.
-2
By 0.5?
by 0.5.
Oh,
Negative
yeah,
20.
-20.
That feels weird.
Yeah, I don't know.
It feels weird, doesn't it? You're dividing. And so far, gentlemen, ladies, most of your experience with division has been when you divide by something, your number gets closer to 0. It gets smaller. And here, I divided by something and my number got further from 0. It felt like it got bigger. What the fraction?
Isn't it because they're negative?
It's because we've got a fraction.
Oh.
The denominator itself is a fraction. Remember that I can replace that 0.5 with half. And whenever I have this complex fraction thing happening, I divide by a fraction. I can take the numerator, leave it exactly as is, replace the division, that fraction bar, the first one, with a multiplication, and then take the denominator, the thing on the bottom, and flip it into its reciprocal. And so 10 divided by half is exactly the same as 10 times 2, which is why -10 divided by 0.5 feels bigger, it's further from 0, than you expect with a division. And it's because that denominator is smaller than 1. I hope that cleared up a kind of a long-standing confusion you guys might have had about division and fraction.
Oh, I was confused, like, since, like, algebra 1.
Right? Well, did that clear something up? Woohoo! I love it being able to do that. All right, let's look at this next one. What about this one? What do I do? Yeah, x equals y plus 2, so what should I do? Substitute. So everywhere I see an x, I'm going to replace it with y plus 2. On this substitution, just like in the first one, I highly recommend that you write the thing you're substituting inside of parentheses, because this means 8 times y plus 2. If I don't put the parentheses, what I've written means 8 times y, that plus 2. Okay? This means 8 times the group y plus 2, and this means 8 times y, and then plus 2. Okay? So I recommend put those parentheses in there. All right, then I can solve this for y.
8y plus 16 plus 9y equals 1.
Oh, you're so good at this, man.
Minus 16, right? And then you combine 17y equals And then you can divide by 17.
Yeah, I can divide both sides by 17. And I end up with a weird fraction. I didn't do anything wrong, you know. I substituted properly, I distributed it properly, I subtracted and added and divided properly. It's just a weird fraction, which is fine. I don't really know how much pizza that is. I think it's a lot because there's like 17 slices of pizza.
But it's negative 15.
And there's like a 15 slices of it. Like, this feels like it's a lot of pizza. Like, I'm hungry. Right?
But then you realize that it's 15 slices.
Yeah, I could dig into this a little deeper if I wanted to really figure out how much pizza this is. Where did I mess up? Okay. All right. Well, thank you for making us stop and question and look again. I appreciate that. So I could dig in to figure out how much pizza this is, but then again, I could just as easily not. Yes?
Jeffrey King, come
Yeah.
into the office for a bit.
Yes.
Jeffrey King.
Yes. Thank you. The voice from above has spoken. All right, let's look at these four things. So these lines, these equations, make much more sense if you're able to see the picture of what they represent. So in this picture, we have two lines. One is maybe a cost of something, and another is maybe how much money we make, and our break-even point is where they touch. How many break-even points do I have?
On the first one?
On the first one.
Just one.
Just one. That's the number of solutions I should expect to find. It doesn't tell me what the solutions are. It doesn't tell me where they're located. It just tells me, dude, you have one.
Infinitely.
Letter B.
No, that one's for C, actually.
There's, well, how many times do they touch here?
None. 0.
None. So there's no solutions. 0. It's entirely possible in real life that the problem you're faced with has no solution. And if we're talking system of linear equations, this is what it would look like.
Parallel.
C.
Infinitely many.
Everything is a solution. There's an infinite number of them. Because the lines are the same thing. It doesn't matter what number you pick. It's going to work because you're on the line. So there's infinitely many. I'm going to write infinite number of solutions.
And that one will eventually have one.
And D. You say it's eventually going to have one, but they're not touching.
So that's 0. Right?
That's what I want to say. There's no solutions in D because they're not touching. But they're not touching. So the question is, how many solutions can we expect? Hi, I've got a couple people that are very absorbed in the small screen in front of them. Do me a favor, slide it to the side. I'd like you to be on the big screen, just like the movie theater. Thank you. There's no movie arcade going on here, guys. Thank you. So for D, how many solutions can I expect?
1.
Why? They're not touching.
They will though.
End up intercepting.
But they will, because those arrows means it goes on for forever, and
Right.
eventually
Really close.
they're going to touch. What D is basically saying is, I have my cost for my bags of Chamoy Gummi Bears, and I know how much money I've made so far, and I know eventually I'm going to run into my break-even point. I just haven't yet. But if I continue selling, I will eventually get to my break-even point. That's what D is saying. Okay? All right. So now that we've done that review, let's talk about how we actually go about solving systems of equations using the substitution method. We're going to do them by hand first. Then we'll roll in a bit of technology to make the number crunching easier, though the stories behind the number crunching are going to get a little more complicated before we move on. Okay? So here, to solve by hand, all you need to do is 3 steps. The first step, look at your system and find or create one of the equations so that it is solved for one of its variables. You want one of your equations in your system to look like x equals stuff or y equals stuff. Okay? That's step one. Once you have that, step two is going to be substitute that equals stuff into the variable on the other equation. Solve that down to its variable. Then take that number and substitute that back into the very first equation that you started with. Solving that down for its variable gives you your final answer. Let's apply all three steps. All right, so looking at the system of equations, I've already circled for you the equation that is solved for one of its variables. Here it is. This one is solved for y. This means in my other equation, everywhere I see a y, I'm going to put that stuff y equals right here. All right. I recommend that you write parentheses regardless of where you're substituting, because now I can decide whether I need them or not. To tell if you need parentheses, you check right here in front. Do I have a number? No. Do I have a negative? Then I don't need parentheses. If I have either a negative or a number or both, I need the parentheses to distribute that information into it to get rid of them. Okay? So without those, I can just drop those parentheses. I can now collect like terms. I can now get stuff out of the way. And when I'm done, dividing by 5 gives me my results.
So you're just solving that equation?
Just solving that equation now that I've gotten rid of one of the variables.
So basically just isolated
X. That's exactly what we're doing. Now that I have a value for x, I'm going to take this number, whatever it is, and I'm going to shove it into x in the first equation that I started with.
So it would be 2 times negative 2?
Mm-hmm. Now she said 2 times negative 2 because that's what 2x means. It means 2 times whatever x is. This is why I recommend the parentheses, because if I don't write the parentheses, if I just write the negative 2,
It would be adding.
it looks like I wrote 2 minus 2, but that's not what we mean. She said we mean 2 times negative 2. That's why the parentheses. So negative 3. Very good. And so my solution is the point negative 2, negative 3. This tells me that if I decided to grab some graph paper, draw the 2 lines of the situation that these equations are representing, I would end up crossing at that location. We are inside of the 4-minute mark, and so I want your brains to digest this. When we come back tomorrow, we'll start off with example number 1. All right?
Yes, ma'am.
Thanks very much.